I've always found pumps to be quite interesting, especially simple ones like the diaphragm pump, which has no moving impellers or rotors and instead works by squishing. Let me explain. If I take that tube and I place it in some water and start squishing it, as we would expect, nothing happens. But if we add a series of one-way check valves and do the same motion again, something interesting starts to happen. We'll notice that the water starts to replace the air and move up the tube. Thanks to the one-way check valves, the air that is displaced can only move in one direction, and that's out of the tubing, meaning a suction end is created inside the water which is pulled up to fill the void. This self-priming nature means the pump doesn't need to be flooded ahead of time and is useful for applications like primer bulbs that you'll find on an outboard motor. However, the drawback is that the flow rates tend to be relatively low, and with the small amount of volume we're displacing in our tiny tube means we're no exception. To quantify it, we can measure how long it takes to fill 25 milliliters, and at 2.5 minutes, that's a measly half a liter an hour. To improve this, and since not all pipes are flexible, we can make our own diaphragm that is larger out of a flexible material like TPU, which will increase the amount of volume we displace with each squish. I'll mount it to a housing, and then once again add back on our one-way check valves. Another advantage of diaphragm pumps is that they can run dry, and ours at least sounds like a clown horn. Once again, there's no need to prime it, and we can just start pumping it right away. And this time around, definitely feels like it's a lot faster. Diaphragm pumps typically use motors with an eccentric cam to automatically squish the diaphragm, and while ours is single acting, double acting ones exist that give you flow on both sides of the motor stroke. One way we can remotely motorize our pump is with a servo motor and a microcontroller. This lets us remotely operate our pump with the touch of a smartphone. This also lets us deliver a precise amount of fluid by controlling the speed and the size of the oscillations. The only issue is I clearly made the base a little too thin and is flexing more than it probably should. But the real questions are, can we remotely pump some fluid, and was it faster than before? This time around, we seem to have finished pumping 25 milliliters in about half as much time, or roughly about a liter an hour. The last thing I was curious about is what kind of pressure, or pump head measured in meters, can this little servo motor setup produce. So to measure that, I just hung up some tubing and started pumping liquid till the liquid stalled out. Once the fluid stopped moving up the tube, I measured the height of the reservoir, to then subtract from the height of our water column. Here it looks like we have a head of about 0.77 meters. One application I just thought of for this setup in particular, a low flow rate remotely operated pump, would be for a remote or automatic watering system, since the drip feed is just enough to moisten the soil for certain plants. With that said, I had fun playing around with this little pump setup, and if you'll excuse me, I got a little bit of water to wipe up. Thank you for watching.